students, Unit 2, we are exploring about the PLC architecture and application. Okay, so in this lecture, we are going to discuss the introduction to PLC. What is a PLC? What is the evolution of PLC? What is the need of PLC? Okay, then we will be exploring the principle of operation of PLC. Okay, so how the PLC is performed. Then we'll be exploring the main thing, which is a PLC architecture. Okay, so learning about the input and output devices used in the PLC, and also we are exploring the programming of PLC, programming the programmable controller. That is, the programming can be done using a ladder schematics. Okay, and also we are exploring in this lecture timer and counter, data transfer and data manipulation operation using PLC, also arithmetic operation in the PLC. So coming to introduction to programmable logic controller. So what is programmable logic controller? Okay, it is actually a programmable controller. Okay, so programmable controller is a device which performs a discrete or continuous logic in a process plant or factory environment. Okay, so the main objective of designing or developing a PLC is to replace the relay, okay, which can able to capable of performing the sequential on off controller. Okay, so it is also popularly defined as programmable logic controller or programmable controller, both are same. Okay, so the main objective is this controller was first developed by General Motor Corporation in 1968 in order to replace the relays. Okay, and it has been used in practice in the year 1971. The programmable controllers were being used in the application outside the automotive industry also. So coming to introduction to PLC, earlier the programmable controllers were conceived just a replacement of relay. Okay, as they are capable of on-off control only, their application was limited to machine and process that requires interlocking and sequential applications such as transfer line, grinding and boring machines. The major benefits provided by the earlier machines were the role as a diagnostic indicator to aid troubleshooting, saving of installation space, easily installable and reusable if projects were scrapped. Okay, so that is the benefits of provided by the earlier machines. Okay, whereas a PLC offers advantages in comparison to electromechanical relay. It is economy, smaller in size, suitable modular design, higher reliability, ease of programming, rugged construction, and ability to communicate with the computer. Okay, so that is these are the benefits of introducing a PLC over the electromechanical relays. So coming to principles of operation of PLC, as per the NEMA, that is National Electrical Manufacturers Association USA, it defines a programmable logic controller as a digital electronic apparatus with a programmable memory for storing the instructions to implement specific functions such as logic, sequencing, chiming, counting, and arithmetic in order to control the machine and processes. Okay, and also the ladder diagrams are specialized schematics. Okay, so the program which you are going to document the industrial control logic using a ladder schematic or ladder diagrams, which is going to have like a ladder. Okay, so it resembles like a ladder with the two vertical rails which represents the supply power, and there are many rungs, that is horizontal line, as they are the control circuits to represent. Okay, so it will be like this. If you take a program, you are going to represent the program with the help of a ladder. Okay, so with the help of a ladder, so the ladder is nothing but it is going to have a ladder vertical lines in which the control logic is implemented using the horizontal lines represented by the rungs. Okay, so if you want to draw a simple ladder diagram showing a lamp that is controlled by hand switch, it will look like this. The schematic will be like this. It is going to have a ladder with the rung represents a switch and the lamp. Okay, so here L1 and L2 designations refers to the two poles of VAC supply unless otherwise noted. Let L1 is a hot conductor and L2 is grounded, that is neutral conductor. Okay, in the earlier days logic control functions, timing, sequencing and control were provided using a through the hardwired logic. Okay, later this programmable controllers have replaced these functions using the three basic logic gates like AND gate, OR gate and NOT gate. Okay, so the combination of these functions determine whether the device must be switched on or off. Okay, so the programmable controllers of earlier days use ladder diagrams to program these functions. Okay, so it is going to have a switch and the lamp which is going to represent the logics. Okay, so logic can be implemented in the form of a gates. So coming to the architecture of PLC, the architecture of programmable controllers. The programmable controllers is similar to a programmable computers. That is a computer based. Okay, thus therefore the architecture is more or less similar to a computer architecture. So computer architecture we are familiar. It is going to have a CPU. It is going to have a memory. Okay, so memory plays a very important role. It is going to have a fixed memory like ROM rather than the disk of a computers. Okay, so the application programs are stored in the read-write portion of the memory. Okay, in addition to that, it is going to have a central processing unit, a memory, power supply, input output modules and programmable programming devices. Okay, so this diagram represents the architecture of the PLC. It is more or less similar to a computer architecture where it is going to have a CPU as a main part, and it is going now it is also going to have a memory and programming device. Okay, so in the programming device we are going to store the programs. In addition to this is going to have the input and output modules. So the main part of PLC architecture is a CPU. Okay, so this CPU, it receives the instruction from the memory together with the feedback on the status of input and output devices. It generates a command to the output. Okay, so here it is going to have the input and output blocks. The output is nothing but devices is nothing but the relay coil, solenoid valve, indicator lamp, motors, starters are the typical loads to be controlled. And similarly, it is going to have a set of inputs. Okay, so the input in the form of a switch, or it may be in the form of a push button, select or switch, relay controls on a machine or a process. Okay, so the machine or a process element, it transmits the status signal to the input module, which in turn generates a logic signal for use by the CPU. Okay, and the main thing is the intelligent of programmable controllers is derived from the microprocessor, which has a tremendous computing and control capacity. They perform all the mathematical operations like data handling, diagnostic routines that were not possible with the relay or their predecessors, their hardwired processors. The power of programmable controller depends on the type of microprocessor used. A small size programmable controller use 8-bit microprocessor. High-end controllers use bit slice microprocessor to achieve faster instruction. Okay, so the OS plays a very important role, is a main workhorse of the system. Okay, it is necessary to distinguish between the instruction used by the operating system to the command the microprocessor and instruction used by the program controller to handle the specific control problem. Okay, so the operating system, it will perform the following tasks like execution of application program, memory management, communication between the programmable controller and other units, IO interface handling, diagnostics and resource sharings. Okay, so this is the architecture of PLC. Okay, so during the program execution, the processor reads all the input, it takes a value, and according to the control application, the program energizes or de-energizes the output, that's solving the ladder logic. Okay, so once the logic has been solved, the processor will update all the outputs. Okay, so process of reading the input, executing a control application program and updating the output is called as a scan. Okay, so during scan the processor will perform the housekeeping task. Okay, so there are four tasks in the PLC. One is the input scan, second is a program scan, third is output scan, and the last is a housekeeping. Okay, so this step will keep on repeating. Okay, so input scan means it detects the state of the input devices that are connected to the PLC. Okay, program scan means it this execute the user created program logic. Okay, and the output scan is it either energize or de-energize all the output devices that are connected to the PLC. And finally, housekeeping is this step includes the communication with programming terminals, internal diagnostics, etc. Principle of operation, understanding the architecture of PLC, coming to the principle of operation. Okay, so this diagram represents the ladder diagram rung in which it is going to have a 4 inputs and 1 output. Okay, so all this are normally open contact. Okay, so the output may be like a control relay, pilot light, etc. Okay, so here your output. Okay, so you have a 4 inputs x1, x2, x3, x4. So these two are connected in series, these two, 3 and 4 are connected in series, and overall is connected in parallel. Okay, so if it is connected in series, you call that as a AND combination, x1 and x2, and if it is connected in series, x3 and and x4, and overall it is connected in a parallel, and your output will be x1 and x2 or x3 and x4. Okay, so in this way we will implement the ladder rung schematics. Before going to the programming a PLC, let us see what are the input and output devices available in the PLC. The following are the common input output devices used in the ladder rung. Okay, input devices are, as I discussed in the architecture, it is going to have a push button, selector switch, proximity switch, limit switch, timer contacts. And similarly, output devices are control relay, solenoid valve, pilot light, horn, timer. Okay, so symbols used in the ladder rungs have a specific functions. By and large, they do not represent the input output device specification but do convey the specific switching function. Examples of ladder symbol are, you can represent here, it is normally open contact, or if you have a bar in between the two switch, it represent as a normally closed contact. Okay, so inputs are always represented like a switch and the outputs are represented like a coil. Okay, so this is normally open coil, and if you have a bar in between, so it is not, it is a no output. Okay, so this represents the input and output devices used in the ladder rung. Logic operation. First is the AND operation. How we are going to execute the AND operation in a PLC. Okay, so AND operation is purely a series circuit. Okay, so let us take a series circuit having a 3 inputs and 1 output. Okay, so we'll represent like x1 and x2 and x3. Okay, all are connected in series fashion. Your output is y1. Y1 is equal to x1 and x2 and x3. And similarly, you'll take a second rung schematic which is going to have a 3 inputs x1, x2, c1 and 1 output y1. Okay, so you represent y1 is nothing but x1 and x2 and c1. And similarly, you have another AND operation which is x1, x2 and this c1. You find it is normally closed contact, so no closed contact you represent as a not C. Okay, so here x1 and x2 and not C1, that will be your output y1. Okay, so in this way we represent the AND logic operation using a PLC. So similar to AND logic operation, let us move to the OR logic operation. Okay, so in a OR logic operation, here the contacts are connected in parallel to each other. Okay, and it is connected in series to the output device. Okay, say for example, you represent the two switch input switch x1 and x2 which is connected in parallel. So what is your output? Output is nothing but x1 or x2, that is called as a OR operation logic. And similarly, you have a two inputs like x1 and c1, and what is your respective output? Both are connected in parallel. So if it is connected in parallel, you represent as x1 or c1, that is equal to y1. Okay, and similarly you take another input x1 and c1 is not. Okay, so x1 or not c1, then your output is nothing but x1 or not c1. Okay, so in this way we implement the OR operation in a PLC using a parallel circuit. Okay, Under NOR operation series and parallel circuit, let us move to programming of programmable controllers. So the basic ingredients of language for programmable controllers are same as a computer assembly language. So it is going to have a data transfer, data manipulation, arithmetic and logic, flow control, specific function. The computer engineers know that these operations are common in any computer-based system and only their representation differ, not to say that they are always special requirement of system and environment. They are covered under the special features, functions. Okay, so maybe a lower level or higher level. So lower level is always ladder schematic and Boolean mnemonics. Higher level is functional block and English statements. Okay, so these are the different type of programming languages known to us. So coming to the ladder diagram instructions, we have a relay logic operation. Okay, so let us explain the concept of relay ladder diagrams. Let us consider all the relay diagram instructions commonly available. This is normally open contact, this is normally closed contact, and you have a coil, energized coil, and you have a de-energized coil, which is turn on output or turn off output, and you have a latch coil. Okay, latch coil is there, and there is one more coil which is called as unlatch coil, and also there is off on transitional contact provides one shot pulse whose width is same as a single scan time, and similarly on off transitional contact which provides a one shot pulse for one scan time with when trigger makes on to off transitions. Okay, so these and all different type of relay ladder instructions which is used in the PLC programming. Coming to timer and counter operations, so this timer and counter operations are readily available in the PLC. There is a on delay timer available and there is a off delay timer. These are all readily available function blocks available in the PLC. Okay, so both the on delay and off delay timer is going to have a predefined value, that is preset value, which is decided by the programmer and stored during the execution of ladder rung. Okay, and there is a time base is there. Okay, so you have to define how many what is the delay it has to be, make the particular sequence should get on or particular sequence should get off. Okay, so this instruction is used to perform the delay function for any event when the logic continuity is present. Okay, that is on delay, and similarly off delay, you are having a similar to on delay, you are going to have a preset value and the time base. Okay, so these and all the basic timer operations used in the PL. Okay, in addition to on delay and off delay timer, there is another timer called as a retentive timer. Okay, so when it is required, the timer should not lose the count value when power fails. Okay, at that time we use the retentive timer output. Okay, the instruction is used. The operation is same as T on instruction. Okay, and there is a retentive timer reset. If logic continuity exists, this count is reset to 0 in a retentive timer. Okay, next moving to the counters. Okay, so there are up counter and down counters are there. Okay, similar to a timer, there is a up counter which keep on increasing, increment the counter value by 1, and similarly down counter will keep on decrement the count value by 1. Okay, so this is CTV, another one is CTD, which represents the up and down counter. Here also we are going to have a preset value, that is PR. The data transfer and data manipulation operation. The group of operation involves reading and writing of data from the memory or a register and comparing two data to equal to or less than greater than conditions. Okay, so we'll have a inbuilt functions like ADDR. Okay, so which is going to get the word, and we have another one ADDR which is going to put the word. Okay, so get the word, put the word, compare it is equal or compare less than or compare greater than. Okay, so these are all the readily available blocks in the PLC. Okay, which is going to perform the data transfer and data manipulation functions which is available in the PLC. In addition to this, there are some of the arithmetic operations like addition, subtraction, multiplication, and division are also performed. Okay, so the operands may be two memory location content with results stored in one or two memory locations. Like you have a addition, have a subtraction, multiplication, and division. Okay, so the addition of two operand values specified, and the resultant must be one of the operand location may be specified separately. And similarly, subtraction same, and similarly multiplication and division. These are the arithmetic operation performed in the PLC. Okay, so this is a readily available block available in the PLC. So where you will feed the value of input to input value and you will get the output. And similarly for subtraction, multiplication and division. Okay, so these are the and similarly this is the functional block represents the timer. Okay, so and this is a functional block represent the counter. Okay, and this a functional block represents the sequence where it is going to have both the control, reset pointer, and output. Okay, so with this the PLC architecture programming and principle of operation and some later schematic represent the logical operation, data transfer, and also data manipulation, and also timer counter arithmetic operations are explained in this lecture. Thank you.